All right, so we're going to be simplifying radicals with any index. So this is a radical. You have your radical sign here. You have the radicand, which is the value inside the radical sign, and then you have the index. This is often, a square root. So you see no value here. It's an invisible 2 often. If you have a cube root, you'd see a 3, or a fourth root, you'd see a 4, where n is. So radicals behave differently based on if it's a even index or an odd index, and if there's a negative number inside the radical or a positive number inside the radical. So I know some of these you probably just know off the top of your head. You've done this for a very long time. But to go over the basic behavior of how to simplify a radical, we use factor trees, where we ask ourselves what two numbers multiply to create the radicand. So in this case, 4 would be 2 times 2. And in this case, since this is a square root, an index of a 2, we're looking for 2 of the same value. We have 2 of the same values right here, and therefore we would write a 2 outside the radical to represent this one circle that I have. So we know the square root of 4 is 2, and this is the algebra behind it. Then if we go to the square root of negative 4, I'm sure if you type that in the calculator, you'd realize it doesn't work. And that's because when you try to use your factor tree to find 2 of the same number, you're never going to get 2 of the same number. You'll always end up with a positive 2 and a negative 2. Or if you went with 4 and 1, a 4 and a 1 of these would need to be a negative before you get negative 4. Therefore, we can conclude that this is a non-real answer, an imaginary answer, and this is where you would actually have your answer of 2i, where I is representing the negative sign inside the radicand, which we basically pull out and make an I, and then we break down the square root of 4 like this. Once again, 2 of the same number, bringing a 2 outside, meaning that the square root of negative 4 is really 2i. Now, if you have a cube root of 8, you're looking for 3 of the same number. So if I use a factor tree, I have 4 times 2. I can break 4 down into 2 times 2. That 4 is no longer there, neither is that 8, because we kept breaking it down into smaller values. But since the index is a 3, I need 3 of the same number to make a circle. Now I can take a 2 out. This 2 represents this circle. Has to have 3 2's because there are an index of 3. Now when it comes to the cube root of negative 8, you can play with it a little bit. You can have, say, a 4 and a 2. One of them is going to need to be a negative. Then if you go ahead and say, well, 2 times 2 is 4, I do not have 3 of the same number. But I can manipulate these numbers a little bit. I can go, well, if this is a negative 4, then it would maybe look like this. Still doesn't work. But if I think to myself, if I go with 4 times negative 2, I know that negative 2 times negative 2 is actually a positive 4. So I could still create 3 of the same number because the index is 3, and I can write a negative 2 outside the radical to represent that. Now no one wants to sit there and try to figure out where should the negative signs go in our factor tree. That's really annoying. We do know that we can actually create this very consistently. Therefore, we essentially can take a shortcut. We can just pull the negative out, and so now we deal with the negative cube root of 8, and then we can just deal with all positives and pull a 2 out. So we would end up with negative 2. You could do it that way as well. The nice thing is if it's a negative and your index is odd, pull the negative sign out and your answer on the outside will be a negative. All right, so now we get down to some of the basic simplifying radicals. So we look at 192. We have a square root, so we're looking for 2 of the same number. So if I take 192 and I try to figure out what multiplies to get me that, I know 2 times 96 will. So 92 is no longer there. Now I'm going to try to break down 96. I can see that 6 times 16 is 96, so that 96 is no longer there. I know that 2 times 3 is 6. The 6 is no longer there now. And I know 16 is 4 times 4. And then I can break the 4's down into 2 and 2, and 2 and 2. So once again, since the index here is a 2, I'm looking for 2 of the same number. So I have 2 of the same number, 2 of the same number, and 2 of the same number. Since there are 3 circles, I'm going to have 1, 2, 3 2's outside of the radical. Now there is a 3 here that did not get circled because it has nothing to pair up with. So it's going to stay inside the radical. But now I have all these variables. I have an x. I need 2 x's to make a circle because the index is a 2. And I don't have that. So that has to stay inside of the radical. I have 4 y's. I can, once again, pair them up into 2 of the same value, in this case 2 y's. There are 2 circles. So essentially I have y squared outside of my radical. So now I can just times it all together. I'm going to have 8y squared square root of 3x. It says use the absolute value signs when necessary. It is not necessary here, and that's because it only shows up when you have an even index, like we have in this situation, and an odd exponent on a variable on the outside. Our exponent is even, so we don't have to worry about this. You only have to worry about it is if your exponent out here is odd, and that's just to ensure that no imaginary solutions get popped into our algebra as we're doing this problem. So here, I've basically made the same problem, but I've changed the index to a 3, which means instead of grouping things into pairs of 2, I'll group them in the pairs of 3. So once again, 192 is 2 times 96, and 96 is 6 and 16, and 6 is 2 and 3, and 16 is 4 times 4, and 4 is 2 times 2, for both of those. But this time, once again, I am now circling in groups of 3. So these are going to get circled, and these 3 2's will get circled. This time, I only have 2 circles, so I'm only going to have 2 2's. I am still left with a 3 that couldn't be circled, so it's going to stay inside the radical. Once again, don't forget your index when you write this out. I have a single x. I need 3 x's to make a circle, and I don't have it, so it stays inside the radical. I have 4 y's. I can circle 3 of them. That's 1 circle, so I have 1 y on the outside, and I have one that didn't get circled, so it stays on the inside. 2 times 2 is 4 y cube root 3xy. Now, since my index is odd, it doesn't matter if my variable ends up being a negative number or not, because it's not going to introduce imaginary solutions. That only happens if the index is even. All right, we're going to just do 1 or 2 more examples. If you understand what to do by now, stop the video and get started on the assignment. If not, here's just another example. So 54 is 9 times 6. I can break the 9 down into 3 times 3. I can break the 6 down to 3 times 2. Now the index is a square root, which means that's a invisible 2. So I'm looking to circle 2 of the same number. I can circle 2 of the same number right here. I will bring a 3 outside the radical because that 3 represents that circle. There are 2 numbers that can't be paired up because they're not the same. Therefore, they're going to stay inside the radical. So I'm going to have 3 times 2. I have 2 a's, 1, 2. That's enough to circle because the index is a 2. So I'll have a single a outside the radical. There's no a's left over, so nothing goes inside. I move on to the b's. 1, 2, 3, and 4. 1 circle, 2 circle, 2 circles, 2 b's on the outside. So now I'm going to have 3a b to the second. Square root 3 times 2 is 6. But this time, since I have an even index, it's a square root, and an odd exponent on the outside, I put absolute value signs to ensure that my a would be a positive number, because if it ever wasn't, it could cause some problems inside the radical potentially. Right? Last one, this time we have an index of a 5. Now that's an odd index. We have a negative number inside. Therefore, we can pull that negative out. So now it's just positive 256, a to the 5th, b to the 7th. And then with 256, I'm going to start breaking it down. So two numbers that multiply to be 256 is 2 times 128. 128 is 2 times 64. 64 is 8 times 8. 8 is 4 times 2. And 4 is 2 times 2. Same thing's happening here. 2 times 4, and 4 is 2 times 2. Now I have a whole bunch of 2's left over, but since the index is a 5, I want to circle 5 of the same number. So 1, 2, 3, 4, and 5. There's one circle. I've only got 3 2's left over. That's not enough to make another circle. So those are going to end up inside the radical. So what I have currently is a negative sign on the outside because of this. Then a single 2 to represent the one circle that I have. I'm going to leave some space for the variables. And then I have my index of a 5, and I have 3 2's left over. 1, 2, 3. Now I have 5 A's. 1, 2, 3, 4, and 5. That's the same number as my index, so I can make one circle. So I'll have 1 A on the outside. I have 7 B's. So now once again, we'll circle 5 of the same number. In this case, 5 B's. I'll have a single B on the outside, but I have 2 left over here that couldn't be circled, so they go inside the radical. So my final answer is 2, negative 2, A, B, the index of 5, 2 times 2 times 2, which is 8, B to the second. And that's how you simplify a radical.